How do closed and isolated thermodynamic systems differ? Imagine you have a container filled with gas. Now, think about what happens if this container can exchange heat or work with the outside world, or if it stays completely sealed off. That's where the idea of thermodynamic systems comes into play. Today, we're going to look at two types, closed systems and isolated systems, and see how they are different. A closed system is like a container that can let heat or work pass through its walls but keeps the matter inside. For example, a pressure cooker is a good example. It can exchange heat with the stove, and steam can escape if the safety valve opens, but the amount of water and food inside stays the same. The key point is that matter cannot enter or leave the container, only energy in the form of heat or work. Now, an isolated system is a bit more strict. It does not allow anything to cross its boundaries. No heat, no work, no matter. Think of a thermos flask that is perfectly insulated. It keeps hot drinks hot and cold drinks cold by preventing heat from escaping or entering. In theory, a perfectly isolated system would keep everything inside exactly the same forever. In reality, perfect isolation is hard to achieve, but a thermos is close enough for short periods. So, the main difference is about what can pass through the boundary. Closed systems can exchange energy but not matter. Isolated systems do not exchange either energy or matter. For example, a sealed pressure cooker is a closed system because it can exchange heat with the stove but not matter. A thermos flask is an isolated system because it prevents both heat and matter transfer. Understanding these differences helps us see how energy and matter behave in different situations. Closed systems are useful when studying processes where matter stays the same but energy changes. Isolated systems are ideal models to understand energy conservation without outside influence. Knowing this makes it easier to analyze real-world devices and natural phenomena, from engines to the universe itself.